Good afternoon, everyone. My name is Brock Johnston. I'm the Public Relations Manager here with the Iowa Soybean Association. Thank you all for joining us today. We appreciate your membership with ISA as always. The Iowa Soybean Association, of course, is driven to deliver the insights, tools, activities, and info to improve the competitiveness and profitability for Iowa's 40,000 soybean farmers. Today's specific webinar on drainage water recycling is a part of our Innovation to Go webinar series led by staff here in our Research Center for Farming Innovation. These have been taking place throughout 2020, and our last webinar will take place next month, actually in September. So for today's webinar, we're joined by Chris Hay. He's a senior research scientist with our CFI team. Just a few quick housekeeping notes here before we begin. So today's webinar is designed to be really interactive. So following Chris's presentation, he'll be available to answer any of those questions that you may have here in real time. So just go ahead and utilize that Q&A feature right here on Zoom to ask any of those questions that you may have throughout the presentation. We'll just be collecting those responses throughout Chris's presentation, and we will have him answer those for you during our Q&A portion towards the end. So with that, I will go ahead and hand it over to Chris, and we can get started.
All right, well, thanks, Brock, and good afternoon. Excited to talk a little bit about some of the work we've been doing with this idea of drainage water recycling. So drainage water recycling is really just an intensified form of water management. And when we think of water management, we all know that crops need water to grow and be vigorous and flourish. But all too often, we get that water either not at the right time or in the wrong amounts. And so we end up with either too much or too little water. And so actually too much or too little water are the largest sources of crop damage and crop loss and yield loss. And so better managing that water is a way to try and improve those yields, that production that we want to achieve. So, in Iowa and across the Midwest, traditionally we've been most focused on too much water, particularly in the spring, which is the larger of our problems here that we face. And so we've built these extensive networks of drainage to remove that excess water and get it out of the field so that we can get in and plant those crops in a timely fashion, and then not have that excess water to impede the crop growth. So we've got great drainage systems that are able to deal with too much water, and in many areas of the state we wouldn't be able to reliably produce crops without those drainage systems. On the other hand, though, those drainage systems are also conduits for nitrogen and phosphorus that leach from below the root zone, and so those drainage systems can carry those nutrients out to our rivers and streams. So that can create both some local water quality concerns, but then also makes its way eventually down to the Gulf of Mexico, where it contributes to the Gulf of Mexico hypoxia or dead zone that forms there annually. And so that's been a big national concern as far as water quality, because the impacts it has on the fisheries and the biota in the Gulf of Mexico. Now, when we think about too little water, that hasn't been as much of a concern in Iowa or other areas in the Midwest until more recently. And we're blessed in Iowa that we've got really good soils that help buffer us when we have too little water conditions. And so in most years, even during dry periods, we've got enough stored water in the soil that although certainly there will be some crop impacts, they aren't as serious as they would be in other areas of the country. But we've seen a trend of longer and more frequent droughts. And so that has become more and more of a concern across the Midwest. And so we have seen increased irrigation across the Midwest as folks try and further boost those crop yields with managing water for too little conditions as well. And then again, if we look at the trends over the last several decades and trends that are expected to continue, we expect in the spring to see more rainfall. So more rain and larger events, which is going to lead to more runoff and also more nutrient loss. And then during the summers, increased frequency and extent of droughts, which will have a negative impact on crop yield. And so that's where this idea of drainage water recycling comes in, that can we take that water when we got too much of it in the spring and then store that in a reservoir and then be able to use that water then as supplemental irrigation in the summer when we have too little water, so that we can then boost those crop yields from that supplemental irrigation. So there's a number of different configurations that a drainage water recycling system can take. And so, it's going to vary on what system makes the most sense depending on site-specific conditions, particularly the topography. But we can usually engineer a system that will work regardless of the field location and characteristics. But how that system will vary. So this figure just shows some different configurations, some different ideas of what a drainage water recycling system might look like. So on the left-hand side, we're actually using sub-irrigation, where we're pumping water back through the same tile lines that we used for drainage in spring, and then raising the water table up below the root zone so that those roots can draw that water up and get the irrigation water that way. On the right-hand side, we've got a little more traditional irrigation system with the center pivot. But it doesn't have to be a center pivot either. It could be a subsurface drip, which some folks have had some interest in, or in the right conditions, there might even be a opportunity for furrow or surface irrigation. So, really any type of irrigation system would work. It's just, again, going to depend on the specific field conditions. As far as the reservoir, if we've got a good spot, a waterway or something where we could create an embankment dam, that's one option. In other cases, we may just have to excavate that storage and then build up a levee to create the reservoir. So the idea is not new. It's been around for a while, and actually some folks at Iowa State, Stu Meldman and Ramesh Kanwar, looked at this idea back in the 80s. And so they did a little study on this idea of drainage water recycling at the ISU, at the time, Ankeny Research Station. So this is just a diagram of what that setup looks like. That Ankeny Research Center, coincidentally, is right in the area where now the Iowa Soybean Association headquarters is located. So it's interesting how some of these things come back around. So what Dr. Melvin and Dr. Kanwar came up with from that study was that they said it appears that there's good potential for the system, especially where higher value crops can be produced. And really that's because of the high investment that's required for the system because of that irrigation component. But they also noted that it could also be feasible for standard field crops where there's where you have to meet stringent water quality standards. And so, the idea then is that you can get both high yields of grain while also meeting water quality standards. And so that's what's really reinvigorated this idea of looking at this practice is that idea of trying to get multiple benefits. And so, the practice really sets itself up for multiple win-win scenarios. So, we already talked about that it helps both with the too wet conditions. We get that good drainage in spring, but then by storing that water, we can also get through conditions where we've got too little water with the supplemental irrigation. Then it also benefits crop yield. So that's a positive for the farmer, but then it also again, can reduce the nutrient loss that we would otherwise have by storing and recycling that water. So we've got a downstream water quality benefit as well. Many of our conservation practices aimed at reducing nutrient loss target either nitrogen or phosphorus, but don't really deal well with both. But this is one that really does help with both capturing nitrogen and phosphorus. So another win-win there. And then by creating that storage in the landscape, if we do this at a large enough scale, by having that additional water storage in the landscape, we can potentially also deal with water quality concern or water quantity concerns. So, flood peak reduction or flooding risk reduction, as well as the water quality benefits that we expect to achieve from the practice. And so it's this idea of, again, these multiple benefits, the multiple win-win possibilities that caused us to want to look at this practice as part of this was a USDA funded study that just wrapped up last year, a multi-state study across the Midwest and North Carolina that Iowa Soybean and Iowa State were part of, along with a number of other universities and the Agri Research Service and USDA. The project was called Transforming Drainage, and so this transformingdrainage.org website is really a great place to get more information on drainage water recycling and the results that we got from that project. And so, obviously we wanted to look at what the potential crop yield benefits were from this practice. And so we only had a handful of sites where we were looking at drainage water recycling, again, because it's relatively recent that we've got this newfound interest in the practice. And so 6 sites across the Midwest where we were able to have several site years of data from this practice. And in 64% of those site years, there was an increase in yield from having that drainage water recycling. And on average, that yield increase for corn was 19 bushels per acre. And so what the figure shows there is if the points are above that diagonal line, then that was a year where we had a yield increase from drainage water recycling. If they're on the line, then there was no difference. There's a few there below the line, and we had a couple of sites where they were using sub-irrigation on fields that just weren't well suited for sub-irrigation. And so in some years there was some loss because again, the site wasn't really suitable for using sub-irrigation as the irrigation method. But in addition to increased yield, the other thing that we saw was we reduced the yield variability. And so on the figure there, the orange box is with just regular free drainage. The blue is drainage water recycling. And so the height of the box designates where 50% of the yield values we're at. Then the whiskers that extend up and below those boxes then represent the range of yields that we saw. And so you can see there that the range in yields were less with the drainage water recycling. So not only did we get higher yields, but they were less variable. And so a little more consistent crop production by having that drainage water recycling as opposed to just free drainage. Then we also wanted to look at when the most critical periods were for having that irrigation, because building storage is going to be expensive, and so if we want to optimize how we use that supplemental irrigation, then we really need to know when to focus on having that irrigation water available to be able to apply at the most opportune times to get the biggest bang for the buck from that irrigation. And so looking for corn, again, what we found was that really from that V9 late vegetative stage into the early reproductive R1, R2 stages were the most critical times for having that supplemental irrigation. And so the green shaded areas there are the areas where drainage water recycling outperforms, again, just regular free drainage. And so really anything of less than 5 inches of precipitation during that V9 to R2 range of stages was when we saw a big benefit from having that drainage water recycling. And then just another figure to kind of to illustrate that. So drier conditions during that V9 to R2 period was when we saw that big bump in yields from having drainage water recycling. As we moved into more normal or wet conditions, then the yields were basically the same. And so again, anything less than 5 inches, but certainly 4 to 3 inches or less of rain during that V9 to R2 was when that supplemental irrigation really had a big impact and resulted in pretty sizable yield increases. So that was, what we saw across the Midwest as part of this Transforming Drainage project for drainage water recycling. But unfortunately, we really didn't have any sites in Iowa to look at that. And so doing some work with Matt Helmers at Iowa State and others there, we were able to study a site actually that was put in just outside of Story City by a farm family that was interested in this idea and went ahead and put in a site on their own. And so they had a site that was ready made to go ahead and look at what the impacts of this practice would be here in Iowa. And so they installed that system in 2015. The field there is on the right. And so you can kind of see the circular area where the center pivot is. So that's about 60 acres that's irrigated with the center pivot. The other shaded portion to the north then is part of the same field. With similar soils, basically the same management. And then we were able to compare the yields historically, and the yields across that field were basically the same. So that gives us a nice kind of control and treatment with the same management, same soils, but then with and without irrigation to be able to compare to. And so then based on the yield data that we were able to get from them, again, we can see that in most years there was a benefit from having that supplemental irrigation. And then especially in 2017, where again, it was kind of dry there during that critical period, we saw a huge yield bump from having that supplemental irrigation. In some other years, it's a little more modest, those yield increases. And then, 2019, they actually didn't need to irrigate at all. And so there's some years where basically there's no benefit. But overall, from 2016 through last year, there was an average increase of 36 bushels per acre on compared to the rain-fed conditions as far as corn yield increases. So that gives us a first look at what the potential might be here in Iowa, but we wanted to look at what it might look like over a longer time span. And so working with some of the crop modelers at Iowa State using a crop model called AppSim, we could actually model what the potential impacts might be. And so we used a study period of 1980 to 2019 using continuous corn because we have the most data for corn right now. And then we looked at kind of historical conditions. So what would we have expected over that 1980 to 29 period if we had drainage water recycling? But then also, since we know that the rainfall patterns are changing and will continue to change, we looked at what some of the climate projections suggest, that something like 15% greater precipitation in the spring and 15% less in the summer. And so what things might look like as we go forward into the future. And so we were able to fit that model so that the model gave us basically similar yields to what we saw in reality. And so that gave us some comfort that the model was working to give us an idea of what this might look like into the future. And so with that, we could kind of look at how much water would it take to realize the benefits of a drainage water recycling system. And so we looked at storage of 4 inches of water, 6 inches of water, and then if we had an unlimited irrigation water capacity. So the green is the baseline or historic yield increases, and then the blue line is that climate projection scenario where we've got more rain in the spring, less rain in the summer. And so with both of those, certainly saw a big benefit with just 4 inches of water. But once we got to 6 inches of water, we really didn't see much of a difference between that and an unlimited water supply. So something around 6 inches of water is really probably going to be the sweet spot to maximize the yield benefit of a drainage water recycling system. But even if we can't get to 6 inches of storage, 4 inches of storage is still a pretty sizable benefit. Then, of course, we also wanted to look at what the potential return on investment of a system would be. And so we looked at what the mean annual profit would be for a system. Again, looking right now at continuous corn. We used corn prices since 2000 as far as what the price model was. And then with that, again, looking at different levels of irrigation water availability in that baseline historic scenario, for 4 inches of water, we're still not coming out ahead with that drainage water recycling. With 6 inches, we're starting to get closer to break even. With unlimited, we do break even. But then as we look at those projection scenarios with wetter springs, drier summers, then all of a sudden now it starts to pencil out and become more profitable. So, I think it gives us a little bit of hope anyway that the irrigation system itself may be enough to pay for itself as we move ahead. But then with that potential for multiple benefits, maybe that's another way to help financially incentivize the system. And so another thing we wanted to look at then was what were the water quality benefits of these systems, because that could be a way to help finance these systems either through cost share or environmental services, ecosystem market type systems as another way to try and pay for the systems. So a little study that we did with Iowa State and Purdue researchers, again, kind of modeling systems in Iowa and Indiana, looking at some different situations there. We were able to see about 24% to 37% reduction in nitrogen loads from those systems by having the drainage water recycling. And then for dissolved phosphorus, we saw about a 21 to 39% load reduction in dissolved phosphorus. So again, we've got that benefit of reducing both nitrogen and phosphorus losses from the system. Beyond the water quality benefits, there's potentially other benefits that we can get from drainage water recycling systems as well. And so, some other things that we might consider as we look at these systems in the future, if it's part of a larger drainage infrastructure, so say as part of a drainage district or where we've got multiple drainage systems combined together, by having that storage, we can open up some of that drainage capacity at times when we need that full drainage capacity by diverting some of that water into storage. And so that can actually help enhance our drainage benefit in those conditions where we really need that drainage capacity. Then again, by having that landscape water storage, if we do enough of these where we've got enough of those reservoirs out on the landscape, again, we've got that potential to store and buffer some of that water that could potentially reduce some downstream flood impacts. There's also the potential for wildlife benefits, and especially if we create some shallow water habitat as part of that storage. Well, we've got the potential to create some benefits for different wildlife species, and we could tailor those designs and management to benefit those if that's a priority for us. And so some of the work done in Ohio, where they actually built in some wetland habitat along with the storage for the irrigation water, they saw large increases in amphibian habitat and other wildlife benefits with those systems. And then one that's maybe a little more futuristic, but certainly a possibility as well, is something that's called photovoltaics. So it's actually floating solar panels on top of that storage. And so by having that area where we can put some solar panels and capture that sunlight and convert it to energy, we can actually help produce energy with that system as well, which could be a help as far as some of the pumping energy that may be required for the system as well. And then another benefit is by having those solar panels there shading the water surface, we'll get less evaporation from that water surface, and so we can store more water that way, or reduce the losses of the water that we do store. So again, a number of potential benefits from this system, and does show some great potential, but there's still some research needs that we need to continue to look at as we try and advance in this practice towards wider implementation. And so that's another thing that we wanted to look at with that transforming drainage project is what's needed to continue to move this practice forward. And so again, one of the things we really need is just more monitored field sites. That we've got a fairly limited number of sites that we've looked at this at. And so the more different situations that we've got to compare against, the better picture we'll get of how this practice performs. And so we're fortunate here in Iowa that we've got 2 new sites that are coming on board. So working again with Iowa State and then the Iowa Department of Ag, we've got a site that is now up and running in Calhoun County, another one that's close to being ready in Webster County. with the potential for potentially adding even a few more new sites to be able to research this here in Iowa to get a better idea of what it looks like within Iowa. One of the biggest questions is still, how much water can we capture and then have to be able to reuse as irrigation, and how does that vary from site to site? And then with that, then how do we actually design these systems and manage them so that we maximize the productivity and the profitability of the system so we get the maximum economic benefit? And then obviously, what are the water quality impacts? Because that's another real benefit of that system and could also help in the financing of those systems. And then how can we design and manage them to get other benefits and avoid any unintended consequences? So one of the tools that we developed as part of that Transforming Drainage project is this tool called Evaluating Drainage Water Recycling Decisions, or EDWARD for short. And so with this, it gives folks a chance to kind of explore and play around with what a system might look like for them. And so they can look at different storage amounts. And so, it starts with a map interface where you select where your site's at. And then by putting in a little information about your field, and then what kind of reservoir you might be looking at, you can start to put in different size reservoirs and get an idea of how much water you might be able to have for irrigation, and then what also will give you an idea of what the water quality benefits of that would be. And so when you put that in, here's an example of what the output it will give looks like. And so this is an example for a field in Calhoun County. And so we can look on the x-axis or on the horizontal axis there at different reservoir sizes. And then on the vertical or y-axis, then we've got different irrigation amounts. And so on average, for all but those smallest reservoir sizes, we're looking on average at about 2 inches of irrigation applied per year. But that ranges from years, again, where we really don't need any irrigation to years where we're putting on 6 to even over 8 inches of irrigation water. And so again, it's those years where we have a pretty high irrigation demand where we're going to see that maximum yield benefit as well. Then on the water quality benefit, an example here for nitrate load reduction losses. And so, as we get into the larger reservoir sizes, we're looking at 20% up to almost 40% load reduction in nitrogen losses. So that water quality benefit that goes along with the crop yield benefits as well. Another thing that we've done is work with NRCS to get this as a practice within EQIP. And so we worked to actually modify what was an existing conservation practice called irrigation tailwater recovery, which is a fairly popular practice in the Mid-South region of Arkansas, Mississippi, down in Louisiana, and up and a little bit into Missouri, where they're capturing runoff from surface irrigation and then recycling that water. So kind of similar idea to what we're trying to do with drainage water recycling. And so we modified that practice standard to now include drainage water as part of that purpose. And so the new practice standard is irrigation and drainage tailwater recovery, is an improved practice now at the federal level. Unfortunately, it's not yet approved at the state level in Iowa, but hopefully Iowa will adopt this practice sometime in the near future, and then it would be available for EQIP funding through NRCS. So that could be another way to help finance one of these systems. At the state level, IDALS, or the Iowa Department of Ag, has shown an interest in this practice as well, and they've been working with us in Iowa State to study this practice. And so there is potentially some interest at the state level too, as far as funding the practice as well. At this point, they're not able to fund the irrigation system, but they can help fund the storage and some of the other components that would go with the system. And so that can be another way to help offset the costs of a system. couple things as far as resources for more information. This was an extension publication we put together as part of that Transforming Drainage project. So questions and answers about drainage water recycling for the Midwest that talks about some of the most common questions that we get as far as this practice, and gives some answers for those. And then focusing then on what we saw for the corn yield impacts. There's also this corn yield response to drainage water recycling. Another one, another kind of research need is most of the sites so far have just used sub-irrigation. So we don't have as many sites where they've used center pivots or a different irrigation system. So the two new sites in Iowa will both have center pivots. And so, some of these new sites will give us some ideas of how other irrigation systems work with this practice as well. And then for those that like to get some information via videos, there's also a series of videos on drainage water recycling, including some case studies from some farmers that have put in these systems in Michigan and Minnesota. So it's kind of a nice little series of videos to talk about the practice. And so with that, then just to kind of wrap up what I've tried to cover here today. So we know drainage water recycling will increase yield, as well as also reduce yield variability. So we'll get more consistent yields over time with that practice. The potential profit from the system really depends on prices and then also precipitation patterns. So, if we continue this trend, which we expect it will be the case of more rain in the spring, less in the summer, then that's going to set itself up for really maximizing the benefits of this practice. Those benefits, again, are expected to increase as those rainfall patterns change. But really, we need to continue to research it and really need to continue to quantify what the benefits are, both for crop yield, but also some of these other benefits, in particular the water quality benefits, because that may be a way to help finance these systems and really pair the private benefits to the farmer with the public benefits for water quality. And so, if there's public investment in those water quality benefits, that can help finance and incentivize these systems so that we get both those crop yield and those water quality benefits. So hopefully, again, everyone wins from these systems. So with that, I will turn it over back to Brock and see if we've got some questions.
Yeah, thanks, Chris. That was great. We'll move into the Q&A portion of our webinar now. So just a reminder to everyone on the webinar today to just go ahead and use that Q&A feature at the bottom of your screen if you have any questions for Chris. So we'll just go ahead and get things kicked off. We had a few questions come in throughout the presentation today. So it looks like if we get things started here on the front of cost effectiveness of implementing a practice like this, we had an audience question. How much does a drainage water recycling system cost, either upfront, or?
Sure, and I'm going to give the unpopular answer of it depends. It's going to depend certainly on what type of irrigation system you use, and so if you've got the right type of field, and by that I mean where you've got a fairly flat area and you've got your tile lines, you've got a pattern tiled field, and the tile lines are close enough together, you can use that idea of sub-irrigation where you put the water back through the same drainage system and raise the water table up below the root zone where those roots can get it. That's a way to potentially save on cost, and you get the benefit of using the drainage water system both for drainage and irrigation. So there's some cost saving benefits that way. But again, it's really limited to those conditions where that practice is suitable. And actually, if it's something you're interested in, that's another resource we've got on that Transforming Drainage website. If you go to the tools section there's a sub-irrigation suitability map. And so that'll give you an idea of areas that are suitable for sub-irrigation. So with that, it's going to depend on if you've got to do some more in the drainage system to be able to make that work, or if it's basically ready to go, then there's not a whole lot of extra costs on the irrigation system. But the storage would still have to be paid for, and so that's going to be a fairly sizable cost. A center pivot, center pivot that's going to irrigate about a quarter section is going to be somewhere in the range of 300,000 for a new system. There are potentials for used systems that would help save on costs, but a new system is going to be somewhere around that. So that's the cost of the irrigation system as well. But storage is really going to depend on if you've got a spot where you can create an embankment dam, that's going to be cheaper. If you've got to excavate it all, that's going to be quite a bit more expensive. And so it's really hard to put a good rule of thumb number on what the storage is going to cost. That's really going to vary from site to site.
Awesome. And then in the same kind of realm here, so you had touched on it about halfway through through the webinar today, but as far as any specific programs or entities that could help set off those financial costs for drainage water recycling systems specifically, can you talk a little bit more about that in terms of that specific system?
Sure. So yeah, we're hoping that NRCS will go ahead and improve this in Iowa, and so that would make it available through EQIP. We're not there yet in Iowa, but again, hopefully that'll happen here before long. But in the meantime, like I said, IDALS, or the Iowa Department of Ag, they've shown some interest in this, and so there may be some potential there within their wetland program, and especially if you do create some shallow water areas as part of that storage, that they can help with some of the financing the storage, which again is a big part of the cost. And then some of the works that would go with that storage. The irrigation itself would be on the farmer, but I think that's where promising from the look that we did take, that it looks like the irrigation system may be enough to pay for itself if you can get some help with the storage. And then as we look ahead, what we're hoping is that as some of these ecosystem service markets mature and become more prominent, that hopefully that would be another way to help pay for these systems, is that if we can quantify what the water quality benefits are, then we can maybe pay for those through market-based approaches, and so you get an annual benefit from those water quality benefits that you're providing.
And then moving into kind of that capacity, that water storage capacity, how big would you say what a reservoir would need to be to have that impact on the field?
Yeah, so it looks like kind of the sweet spot is about 4 to 6 inches of water. 6 inches is better, 4 inches is pretty good relative to the area you're irrigating. So again, if it's about a quarter section, you're probably looking at about a 4 to 6 acre surface area reservoir, assuming about a 10-foot average depth. So again, it's going to vary a little bit from site to site, but that's at least an idea. Some of the work we did looking at this potential sites in Iowa and Indiana suggested about 2 to 4% of the area that you're irrigating would be the surface area that you need for that reservoir to try and get that 4 to 6 inches of storage.
Right. And then in terms of, you touched on flood control benefits, Chris. How much, volume per acre or foot of soil can be stored using the system? And is that a meaningful amount in terms of what the system can hold?
Yeah, so, try not to push the flood control benefits too much yet, because it really would have to take a lot of these to see a meaningful impact on flood reduction. So just 1 or 2 sites out there, a handful here and there is not going to have much of an impact on flood reduction. It would really take a lot of these across the landscape to have a big impact. The other thing is the system would have to be managed to really get those flood reduction benefits. And so we need that storage to be fairly empty when we're expecting those big rainfall events that are going to likely lead to flooding, so that we can capture that runoff and store it, as opposed to letting it go downstream. Whereas the farmer's interest is trying to keep as much of that irrigation water as possible. So they want to keep that storage as full as possible. And so, that's again where we'd probably need to look at financing mechanisms to incentivize that if the farmer has to release some water to open up some flood storage, that maybe there's a payment mechanism where they can get some benefit for creating that flood reduction benefit, so that they offset the cost of that lost irrigation water. So that's an open question that we really need to look at as far as how we would manage these if flood peak reduction is one of the primary goals.
Okay, and then moving on to another audience question here. So how would the drainage water recycling affect tillage?
It wouldn't necessarily have to affect tillage, but certainly, it would be a component of what you would want to think about. And so, especially on soils that you might be potential for rutting, if you're using a center pivot. So some soils are going to be prone to getting ruts where the wheel traffic is from those center pivots. And so if we can reduce tillage and go to no-till on those types of systems, and potentially cover crops as well, are a way to try and really benefit that soil structure and that soil trafficability. So we reduce the rutting from the center pivot with sub-irrigation or subsurface strip, those types of systems. It wouldn't really matter what tillage you're using, but may help lend itself to moving to no-till if you have that combined benefit of having the drainage in the spring, but then able to replenish that water in the summer, and taking advantage of no-till's impact on reducing evaporative losses. So.
Right. And then if I'm a farmer or landowner, et cetera, up front, what are some of those, what are those qualities that you're looking for in those kind of research sites in terms of, setting up this practice and studying the benefits, and what does that look like in terms of steps for, a farmer or landowner?
So, going to depend a little bit on again what we might look at as far as irrigation. So if we're looking at potential for sub-irrigation, we're going to want a site that's suitable for that practice. So we want one that where we've got a pattern tiled system, we've got a fairly flat field, where we've got a good restrictive layer on the bottom of that field, which in most cases, if we've got drainage, that's the reason we've got drainage, is because of that restrictive layer. So that's usually not a concern, but we want soil that can move water above that restrictive layer. So we don't want real heavy clays, or else the water won't move in between the tile lines. So that's what we would look for sub-irrigation site. If we're looking at a center pivot, we'd really ideally like a site where we can get a full circle with the pivot. And so we want a nice square field where we can run a full circle with the pivot. If we've got a windshield wiper it on an odd shaped field, then it's usually not quite as financially feasible. It's a little more expensive per area irrigated that way. And so if we've got a nice field that sets itself up well for a pivot, that's going to be a good site to look at for that type of system. Subsurface strips a little more expensive overall, but can make sense in some of those smaller odd shaped fields. And then we want a place where it makes sense to store water. So we're ideally not going to want to take really productive land out of production to create that storage reservoir. So if you've got an area that's either constantly wet, really low productivity, that would make sense to convert into water storage, or just some areas that aren't in crop production right now, but could be used for water storage. That's going to be kind of the ideal situation. So we minimize the cost of that storage by not taking productive land out of production.
Awesome. And then in terms of, that very first step after learning about kind of the practice in the background, do you recommend, a farmer landowner reaching out to Iowa Soybean Association and speaking with, an RCFI staffer, or how would you recommend that going?
Yeah, that'd be one first step. We're certainly happy to try and answer questions here. The folks at Iowa State are another resource as well. So some of the extension ag engineers with Iowa State, and so there's some different field ag engineers. They could be another potential resource. And so, I think between Iowa State and Iowa Soybean, those are going to be the two best places to start.
Awesome. All right. Well, yeah, audience, if you have any other questions, feel free to drop them there in that Q&A in the time that we have left here. We'll try not to keep you over the time today. So just a huge thank you again, Chris, for joining us today and sharing that expertise with the group today. To our audience, we hope that you found today's webinar beneficial as you continue making those decisions for your operation this year. Again, our last Innovation to Go webinar of the year will take place next month in September on Tuesday the 13th. So if you are interested in joining that webinar will focus on the keys to improve soil health, water quality, and profitability, and that will be hosted by our ISA conservation agronomists. So you can register for that opportunity or even go online to our website and complete a research trial interest form that will get you in touch with our RCFI staff and will facilitate your info accordingly. So on behalf of the Iowa Soybean Association, again, thank you, audience, and Chris for joining us today and sharing those insights with us.